Hello, this is Jennifer Martinez. In today's video, we're going to look at page 55 of our notebook, which is on sections D.1 and D.2 from the appendices in the textbook. They're on quadratics. We're going to multiply, factor, and solve equations. We actually multiplied and factored in the beginning of the course in section 8.1, and we are going to do it again. First, what is a quadratic? We've been dealing with linear expressions and linear equations. Now we're going to be dealing with quadratic expressions and quadratic equations. And a quadratic, if you look at the second part here, the b plus bx plus c, that is the linear part of the quadratic. Quadratic is when we take our linear expression or equation and we add on an x squared term. That is called a quadratic. The a, b, and c are constants. These are just numbers. That's what constants mean. And they are called the coefficients. We've done this before. Let's go ahead and multiply this. If you remember, we're going to use distributive law and we're going to multiply this twice. So this is like taking the x times the x minus 2. So that would be x squared minus 2x. Again, that's like taking the x times the x minus 2. And that's where we get that. And then we're going to do the same thing. We're going to take this 3 and multiply it to both of the expressions on the right. So that would be negative 3x plus 6. Again, that's like taking negative 3 with that x minus 2. So you can see that's where we get the negative 3x plus 6. If you remember, sometimes we use the word FOIL. We use FOIL to remember to multiply each term because we're going to get 4 different terms here. So what does FOIL stand for? So this is like FOIL. That's the FOIL. FOIL stands for, F stands for first on the right here, O stands for outer, I stands for inner, and L stands for last. So you could have taken the first, got the x squared, the outer, got the negative 2x, the inner, negative 3x, and the last. So that's expanding multiplying. We can also simplify this. So if you wanted to simplify this, we realize there's 2 like terms. If you remember, like terms in chapter 1 was terms that were had the same variable parts, and we can add those. So actually, that could be a nice answer. On this one, do not forget, we've had this one before as well, we cannot call this x squared plus 36. You can't just square each one of them. You would have to use FOIL, because I'm going to write this as what the square means, and then there's 2 terms, so that's kind of like FOIL, right? So let's do the FOIL way this time. FOIL first. So first would be x squared, so you could think of it distributive property twice, or we can think of FOIL. So first, outer, so there's the first, outer, that would be plus 6x, and then the inner, another 6x, and then finally the last. And I ran out of room here, so I'm just going to write the answer over here. That is equal to x squared. By the way, you can add these together, so you get a 12x plus 36. That would be the answer. So I'm going to pause now, and I would like you to try exercise 1. Try to expand each product, and then we'll talk about the results in a minute. So go ahead and pause and try this on your own. Hopefully, I'm just going to write the answer down, but then we'll do it. You got something like this. This is the answer. How did I get that? Well, first, I'm going to rewrite it twice, just like we did part B. But now it's all with A's and B's. But we can still do it. So we're going to do the first, the FOIL, a squared, the outer, AB, plus the inner. You could write this as a BA, or you can write it as an AB because multiplication is commutative, so it really doesn't matter. So I could write it like that, or if that confuses you, you can always write in that order. That's how I got the 2. And then the last, that would be B squared. So first, outer, inner, last. And then notice how there's 1's right here. There's no coefficients, so they're 1's. So that's why the 1 plus 1 is 2. That's why you get this answer. So go ahead and do part B. I'll just give you the answer to that one. Here it is. A squared minus, the only thing that's different is the minus 2ab plus b squared. Here's the word. It would be first, outer, it's a minus, inner, and I'm just going to write, instead of BA, I'm going to write AB. What about the last one? The last one's kind of interesting. That one turns out, I'm going to actually have you pause and try it first. What's the answer? Believe it or not. Why? Because when you go ahead and do your FOIL, you do your first, outer, you notice you get different signs. The inner is a plus. I'm going to make that an AB, just so we see that. And you can see there's 1's there, and they cancel out. So you just end up with an A squared minus B squared. So these are the formulas in general. You should kind of semi-memorize these. One is called the perfect squares. So it says, when you're done, use your results to try and fill in the right side. So these are formulas that are in the book. So you can look them up, there are boxes in this section. But if you can see from here, this is kind of like the first one, but instead of A's and B's, it's X and R. So this should be X squared plus, right? Then we have 2XR instead of AB plus the R squared. Now you could just multiply these out and do like you did here. You can do it down here to show that. So X plus R squared is the same as this, which if you FOIL this out, first, outer, inner, last, you end up, these are 2 1's here, so you end up with that. So you could do each of these again, but if you look at this, we've done it with the A's and B's. So what's this one? This should be X squared minus 2. The only thing that's different between these two is the minus. Still a plus there. Just this is the minus. And then those are the perfect squares. And then the difference of squares. This is going to be the difference of 2 squares because if you look at the result here, they're the difference of 2 squares, right? The middle term goes away when they're opposite signs. So here is when they're the same sign, both plus, it's a plus there. When they're the same sign with a minus, it's a minus there. When they're opposite sign, it just goes away. So this should be X squared, because that's like the A, minus the R squared. So go ahead and try exercise 2. Pause that first, then try it. And I'll give the answers in a minute. Did you try it? Well, let's go ahead and do the first one together. So I'm going to do FOIL. That's how I'm going to do it. But you could do distributive property twice. And let's go ahead and multiply those two. So that the first would be the X squared. And the last, I'm going to put the 4 first. And then the inner. We've done this before. That would be a 6x, and this would be a minus 24. So it turns into x squared. Negative 4 plus 6 is 2x minus 24. Try the second one. I'm just going to give the solutions to these in a moment. Here they are. So this is the answer to part B. The first, the outer, the inner, and the last. And then I added these two. This is the answer to part C. I expanded it, and then first, outer, inner, last. These are the same. So this one, we could have done this a different way. Method 2. Let's call this method 1. You could have had this memorized, right? What was it again? Right here, let's write that down. Remember that x plus r squared was x squared plus 2xr plus r squared. X plus r squared is x squared plus 2xr plus r squared. So, if we thought about this, we could square this. That would be 9y squared. And then we can multiply this because it's multiplied here. So that would be 6y, but we double it. 2 times 6y. There's where we got the 12y. And then we squared the last one, which 2 squared is just 4. So 9y squared plus 12y plus 4. That is another method, if you choose. You don't have to do this way. You can always do it method 1, but that is another method.